All right, and we are, we were live all, okay, anyway, I don't know how that's going to turn out, but hello and good day. In geometry, we're covering PO7, identifying the properties of complementary, supplementary, and linear pair angles. No matter how this lesson goes, it's got to be better than how it started, so that's good news for us. Defining complementary, supplementary, and adjacent angles. Have you heard of that word complementary before?
Yes.
It's not angles that are nice to each other. That's not the complement I mean, but the mathematical complementary. What does it mean? Definition. Elise. Yes, two angles. Kind of like with a linear pair, we had to clearly define it as two angles. Same thing here. Two angles that add to be 90 degrees. Okay, two angles that add to be 90 degrees. How about supplementary angles, McKenna? Good. At this rate, we might get to do another objective.
No,
don't be so smart. All right. Two angles that add to be 180 degrees. Okay. We did talk about adjacent angles last week. The word adjacent, Elise? Okay, so in geometry, well, in other things too, but the word adjacent means next to. In the geometry context of angles, it would be two angles that share a side. Okay, two angles that share a side. An example would be something like this. Okay, angle 1 and angle 2 are adjacent angles because they have this side that they share, right? That side is both a part of angle 1 and angle 2. Now, I bring that up because complementary and supplementary angles might be adjacent, but they don't have to be adjacent. Okay, adjacent. They don't have to be. So if you have a 40-degree angle here and a 50-degree angle here that are not adjacent, they're not sharing a side, they can still be called complementary angles. Okay? Same thing with angles that add to be 180. They don't have to necessarily touch to be considered supplementary. All right? So in the diagram that's given there, you are told that angle 2 equals 90 degrees, and the measure of angle 3 is 45. So let's put those values in here. The symbol for a 90-degree angle is a box in the corner. You probably have seen that before. Just because it's such a common angle to use, rather than writing 90, you just put a box there. Then angle 3, 45 degrees. Give me an example of angles that would be complementary, supplementary, vertical, we're going back to that here, and a linear pair, back to that as well. You can pick any of the four. Go ahead, Noah.
A complementary angle, angle 4 and angle 3 are complementary, I believe.
Angle 4 and angle 3. So in order for 4 and 3 to be complementary, what would angle 4 have to be? 45. Is there enough information here for us to determine that it's 45 degrees? Daniel? How? Angle 5's got to be 90 because they're vertical. Okay. So how does that help us with angle 4? Okay, so 6 and 3 are vertical angles. We can use those later on, but therefore we know that 6 is also 45 degrees. I'm still waiting to hear about angle 4 though. There you go, yeah. So these three angles here, 2, 3, and 4, even though they're not a linear pair because it's not two angles, they do make a line. So the sum of angles 2, 3, and 4, and for that matter 1, 6, and 5 as well, have to be 180. And we have the 90 from angle 2, the 45 from angle 3. That does leave only 45 degrees for angle 4. Now before you say, well, yeah, but 4 is clearly bigger than angle 3, remember, you cannot trust what you see. Okay? Things might not be drawn to scale. You trust the given information, okay, and trust the math. All right? So, yeah, I'll do there. So, complementary, angle 3 and angle 4 are examples of complementary angles. Two angles that add to be 90 degrees. What else? Any of the other four, or the other three categories? Elise?
Angle 6 and angle 3 are vertical.
Okay, angle 3 and angle 6, or angle 6 and angle 3, are vertical angles. They are opposite each other, and therefore are congruent. What else? We still need supplementary angles and a linear pair. Supplementary angles and a linear pair. Noah?
Which one should we do? I'll go linear pair, angle 3 and angle 1, I think.
So a linear pair, the definition of that is two angles that add to be 180 degrees.
Oh.
Two angles that add to be 180 degrees. Grayson? Two angles that add to be 100 degrees and, I left this part off, and make a line, right? That's the linear pair. 2 and 5 is our answer for the supplementary angles, because they are two angles that add to be 180. Do we have two angles that make a line here?
No. That make yes.
Yes.
I'll give you a hint. It's one of those two.
Yeah.
Great.
No.
I have no idea.
Don't ever say I never gave you anything. The spirit of Christmas.
Who doesn't know?
Sebastian.
Angles 1 and 2 and 5 and 4.
1 and 2 and 5 and 4. 1 and 2, if I follow the trajectory of their sides here, they don't make a line. And neither do 5 and 4, because I turn there at that point of intersection.
It's 6 and 2.
Luke.
And then 6 and 2.
1 and 3 and 6 and 2.
No.
1 and 3. Well,
No.
1 and 3, they do have sides that are part of that line, but angle 2 is a part of that as well, right? Which is a third angle,
That was my original answer.
which is a problem because a linear pair is only two angles. Boys,
You took my pencil.
Many.
These are all broken.
are there two angles that make a line here? No. So in this case, there is no linear pair. Sorry about that. Yes. Yes, for the help sheet, you may draw the diagram if you'd like. You can put examples of each of them. Yep, because it's under that key point section. You can put the definitions. Moving on down the page. Whoops. Okay. Now that we've learned more and more about angle relationships, we really get to practice with some more complex diagrams and complex algebra here. Folks, again, I'm going to ask you please, okay? In the first one, what relationship, what equation can we set up that's going to allow us to solve for x, Elise?
18x minus 9 plus 4x plus 15 equals 180 degrees.
And someone else tell me why that is true. If someone were to challenge you on that equation, what geometric, what mathematical, definition, rule, law, theorem could you use? Catherine? Did you have your hand up?
Yeah.
Right, because these two angles make a line. That's the definition of a linear pair. We know that their sum must be 180. Okay? How about the next one? What relationship, what equation could we use to solve for x in that one? Gabby?
Would it be 90 plus 6x plus 4x?
We could do 90 plus 6x plus 4x equals 180, right? Because we have a right angle, 90 degrees there, plus 6x plus 4x. Those three angles together make that line. So their sum would be 180. What other equation could we set up?
6x plus 4x equals 90.
We could just go straight to 6x plus 4x equals 90 because DEH being a right angle there, we know that the other side has to be a right angle as well. Okay. Now you'll notice, the first equation that we have here, if we start to solve that, subtract 90 from both sides, well, we end up with our second equation here, right? 6x plus 4x equals 90. So it saves one step by going that route, but either one's fine. The last one, we've got an x variable and a y variable. What can we set up to solve? Why is that writing in red? I don't know. What can we set up to solve for the x variable? What can we set up to solve for x? Thumper.
5x plus 5 minus 100.
Okay, so you went ahead and you combined your 4x and your x. Yeah. So we would probably start 4x minus 100 plus x plus 5 equals 180 because we've got these two angles that contain our x variable that make a line. He went ahead and combined his 4x and his x to get 5 x's there. That's what you need to do anyway, so that's totally fine. Let's solve this one. Let's solve for x here. So we've got 5 x's. And then how do our constants combine? Negative 100 and positive 5 combined to equal what? It's like the front row show today. A lot of participation in the front row. Yes. Not negative 190, negative 95. Yep. So 5x minus 95 equals 180. We can move our constant over to the other side with opposite operations. We get 5x equals 275. 180 plus 95. Divide both sides by 5 to get x by itself, and we end up with,
Oh, wow. 55.
what is it?
55.
55. Thank you. Okay. But we're not done yet, because what other variable do we have in the diagram?
Why?
Because I asked.
You could find out what it is.
You didn't let me get my pun. We'll try that again. What other variable do we have in the diagram? Because I asked. Thank you. Thank you. Thank you very much. Thank you. So,
Do we need to find it out?
tell me 2 ways, now that we have the x value, tell me 2 ways that we could set up an equation to find y. 2 ways. Now that we know what x is, and 55 plus 5 is 60, so we know that this angle there is 60, give me 2 ways, 2 things we could set up to solve for y here. Elise?
One of them is 2y plus 3y plus 30.
Okay, so one of them is 2y plus 3y plus 30 equals what?
Equals
180, right? Kind of the same method that we use to solve for x. We've got these 2 angles here that make a line. So we know their sum is 180. Now that we've solved for x and found that angle there, that's 60, what's another way that we could use? What other relationship now exists that we can use here? Catherine?
Then 5x is across from 2y. 2y will have to equal 6.
Exactly. Using vertical angles, we now know that 2y has to equal 60, right? Either way works. Either way, you'll get a value of 30 for y, which can then allow you to get, the other values there. But that's a nice, once you start putting the pieces together, sometimes other things can open up for you. Okay? But it's all about relationships. The first brain buster. An angle is 3/2 times the measure of its complement. What are the measures of the angles? An angle is 3/2 times the measure of its complement. What are the measures of the angles? So, in a system, Evan?
You want to know how to solve it?
I'd love to, because I'm stumped.
So, it's a complementary angle, so that means it adds to 90.
Okay, so I'm going to pause you right there, okay? Essentially here, we've got two angles that add to equal 90. And I'll draw a right angle just for simplicity's sake, but we've got two angles that sum to be 90. So angle 1 and angle 2, we know that they're going to add to equal 90. Okay? That's what Evan has said so far. And we know that because of this word complement there. Go ahead.
So, angle 2 is 1.5 times angle 1.
Okay. So whatever angle 1 is, which we don't know, so we can represent it using a variable, right? Whatever angle 1 is, we know that angle 2 is 3/2 times that. How do we write 3/2 times x? Evan?
3/2 x.
Just 3/2 x. Right? Whatever angle 1 is, plus angle 2, which is 3/2 times that. So if angle 1 is a number, x, angle 2 is that same number times 3/2, that has to equal 90. Okay? Now, it might be easier to convert that 3/2 to a decimal. What is that in decimal form? Grayson? 1.5. So I'm going to kind of write it over here. So 1 whole x plus 1.5 of x equals 90. Total, how many x's do we have represented there? 2.5, 2.5. So 2.5 x's equals 90. Okay? What do we get as a value for x?
Would it be 36?
36. I'm showing my work going up here rather than. So what that means now is that angle 1, which we identified as just x, is 36 degrees. Angle 2 is going to be 3/2 times 36, or 1.5 times 36. Evan, full circle, what'd you get for that one? 54. What's a great way we can use to check ourselves here? Based on these relationships, Luke?
90 minus 36.
Right. Basically, these two numbers have to add to be 90, which they are, so we know that we're right. But the key here was this part. We know that the two angles must add to be 90, and so if we assign angle 1 to be a variable, x, whatever it is, angle 2 is going to be 3/2 times that. So the next one I'm going to have you do on your own here, it says an angle is 6 more than twice its supplement. So this time, instead of equaling 90, our two angles equal 180. Okay? So again, we have angle 1 and angle 2. We know that angle 1 plus angle 2 is equal to 180. And we know that one angle is 6 more than twice the other one. So like we did here with this x plus 3/2 x, you got to figure out how you're going to represent that as an equation. What's the measure of angle 1? Assign it a variable, and then go for angle 2. In addition to that, you do have a little bit of book homework as well. Oh, you have till Monday. You have what? Oh. Oh. Well, yeah. Your homework is from the book on page 39. Yes, page 39, 20 through 27. Comma. 31 through 38. However, you already did number 33. It was one of the ones on the sheet. So you don't need to. No, we're all good. Yeah, you already did number 33, so you don't need to worry about that one. But page 39, 20 to 27, 31 to 38. Do Monday. Yeah. That, folks, is how you math.